Hi class, may the 4th be with you. Today we're going to start the second part of chapter 6. So let's go ahead and get started. Protocols. So somebody says to you, what's the protocol? It's what's the rule? What's the expected norm? So it's agreed on methods and rules that electronic devices use to exchange information. It deals with hardware connections, controlled data transmission, and file transfers. It specifies the format of message packets sent between computers. You've probably heard of something called TCP/IP. What that stands for is Transmission Control Protocol or Internet Protocol. It's the industry standard suite of communication protocols that enables interoperability. It allows the linking of devices running on many different platforms. So it allows your PlayStation to talk to the internet, it allows your phones to talk to the internet, it allows your phones to talk to your computers. That's the TCP. It operates the OSI model's transport layer. It establishes the link between the hosts. It ensures message integrity. It acknowledges packet delivery, regulates data flow, while the IP is the Internet Protocol. That operates the OSI model's network layer. So now you're seeing IP. You're probably thinking IP address. Yes, exactly. It's responsible for packet forwarding. It's the device's address. It's where they live. It's like your address. If it's 3 North Main Street, another device. Each website has an address. It's the same thing. And there's the network address and node address. Routing. So how do things get to where they need to go? Through packets. It's binary digits, zeros and ones sent from computer to computer over a network. It includes message data and control characters for formatting and transmitting. Routing is the process of deciding which path data takes. It's determined by the type of network and the software used to transmit data. A routing table is generated automatically by software. It determines the best possible route for a packet. So how to get that information or that little byte from one part of a network to another, from one device to another. What's the best route? The decision about selecting a route to follow on the network, centralized routing, where one node is in charge of selecting the path for all packets, while you have distributed routing, which relies on each node to calculate its own best possible route. Routers. They are network connection device containing software that connects network systems and controls their traffic flow. So recently I had to buy a new router for my house, a new wireless router, because my internet was slow. So I needed to buy a more powerful one. What it does is it prevents network jams that delay packet delivery. So if your internet's slow, a router can help it. It handles packets of different sizes. There's a static router that requires the network routing manager to give it information about which addresses are on which network, while there's a dynamic router, which builds tables that identify addresses on each network. It's used more often now, particularly on the internet. So you see more dynamic routers than static routers. Our last term is a client-server model. Software runs on the local computer and communicates with the remote server to request information or services. A server is a remote computer on the network that provides information or services in response to client requests. So it's kind of like the computer in charge of all the other computers. The advantage is scalability. You can easily grow. Think about my room. You can throw 2 more computers on and boom, we've grown. Levels of logic include presentation, how it's returned to the client, application, software processing requests for users, and data management, which is data management and storage operations. And that is it for today. We will pick up tomorrow with 2-tier architecture. Have a great May the 4th, and I'll see you tomorrow. Good night, or goodbye, or good afternoon, whatever. Bye.